Hello, everyone. My name is Lacinio Salza. I'm a product marketing manager at Synopsys, and I'm very excited to be here today to talk about real examples of MIPI interfaces being used in a number of applications such as AR, VR, mobile, and other imaging applications. So in the next 30 minutes or so, we will talk about, I'm going to touch on relevant market trends for MIPI. From my perspective, also summarize the evolution of the MIPI specs, and then we'll dive into real examples of applications using MIPI interfaces. So starting with the camera, well, camera is the electronic eye for any device, and the innovations continue. So in mobile, mobile continues to be the key focus. In mobile, camera continues to be the key focus for mobile handsets, key to enable differentiation. If you look at the bottom on the left side, the example from Xiaomi featuring an impressive 1-inch image sensor, which is amazing. Still, in terms of video quality, the requirements continue to increase. The need for high frame rates, 60, 100 hertz, and also the need to be able to handle complex or challenging light conditions to improve the quality of the image. And this is being done by using dedicated ISPs in some cases. So the example from Oppo below, as you can see, it's a smartphone, is using a very well-known application processor, but they also incorporated an ISP that is responsible for the task of improving the image quality, so paired with the application processor. In XR, this market is gaining some traction, and in terms of requirements, also very sophisticated. We already know the display requirements are very aggressive because the display is so close to the eye. So right now, 4K 9 hertz is something that we expect to see. And when it comes to cameras, they also need to be stereo cameras. They also require sophisticated image sensors with high resolution and refresh rates. In automotive, with the shift from distributed to centralized architecture, bringing more sensors, more fusion opportunities will enable more sophisticated applications such as emergency braking, park assist, and others that will come up. Moving to the display side of things. On the display side, the innovations also continue. Foldable displays expected to become mainstream in mobile. If we look at AR, VR, the micro displays, 4K OLED displays with an impressive pixel density, as you can see at the bottom, comparing a display for a smartphone and a micro display OLED with an impressive pixel density, which again, if you have your display close to the eye, make sure that you don't see those artifacts, those pixel artifacts. That's a requirement for this type of applications. And then moving to automotive, a number of displays in the car, right? Small form factor displays like the rear view, the in-mirror, the dashboard, but these are definitely candidates to use MIPI. They are using MIPI already, and we expect that to continue. And there are also bigger displays in the cluster or for entertainment. Here, MIPI is also a candidate, but there are also other interface technologies that can be used like HDMI or DP. Moving to the edge, calling out this one in particular because there's significant design activity and innovation to enable a smarter experience. So whether it's for home or like smart appliances and monitoring, or industrial and how people interact with retail, all these applications, as you can see here, they're all powered by AI, and most of them have some sort of a face recognition capabilities. So the expectation here is that more and more cameras and displays will be used and are expected to be used in this particular type of applications. And while MIPI is always there to deliver the best conduit, which brings me to the next slide, where I kind of summarize the impressive, the tremendous evolution of the specs to support all these trends. MIPI was born in mobile, but now it's widely used in a variety of applications. MIPI provides the bandwidth, provides the features, enables low-cost implementations, all within the right power envelope, right? So if you look on the right side, different physical layers are available, D-PHY or C-PHY, supporting D-PHY up to 9 gigabits per second, that's the latest, and C-PHY up to 6 gigasymbols per second, which is it's tremendous bandwidth to accommodate all kinds of different applications. Noting that you don't necessarily need to run at the fastest data rate. You can pick and choose what's the sweet spot in terms of operation that you want to achieve. On the left side, I'm kind of summarizing the evolution of the protocol that sits on top of the physical layer, both for camera and for display. A lot of features that are being added to enable sophisticated use cases, like in the case of CSI, DSI, the latest step to include native functional safety capabilities to address the functional safety requirements in automotive. Other features like RAW 24, advanced data types for machine vision, and RAW 28, MPC compression for the camera interface. On the display side, adapted refresh panel to basically enable system level power savings depending on the use case on the phone. And also we already knew about the VESA compression that was already supported. So all in all, again, the MIPI specs continue to evolve to satisfy all types of applications, whether it's for high-end, high performance, or for those applications that need basic connectivity with a very efficient, very efficient in terms of power consumption. All right, so let's move to use cases. And again, I have 3 buckets: automotive, mobile, and edge IoT applications. And I want to go through each one of them individually and touch on some of the examples that are using some of our customers that are using Synopsys IP to address their requirements. So starting with automotive, this diagram kind of represents a simple overview of how the system looks like. The ADAS IVI in the middle, at the center, implementing all these functions that needs to be fed by a number of sensors with supporting different sensing modalities: LiDAR, radar, imaging. These sensors are typically far apart from the SoCs, so they need to come in. That's where the bridge comes in, to bring a long reach bridge to bring the sensor information to the processor. Here's an example from Valence, implementing an A-PHY solution for this bridge, and is using Synopsys IP on both in terms of interfacing with the sensors and in terms of delivering that data to the processor, using C-PHY on the RX and D-PHY on the TX side. In terms of the diagram, so this processor ADAS IVI can be coupled with other processors to increase the processing capabilities. And then when it comes to the display, these displays are also far apart from the SoC, so there's also a need for a long reach connectivity solution to drive the data from the processor to the display itself. In terms of relevant attributes, advanced data types for machine vision, the functional safety, the aggregation capabilities to be able to handle multiple sources, multiple sensing sources, and automotive grade IP to address not only the functional safety requirements, but also the reliability requirements. And finally, the bandwidth, right? We're talking about significant bandwidth here with all these data coming in that needs to be delivered to the SoC. So bandwidth is also an important attribute for these use cases. Moving to mobile, again, still same thing, the application processor in the middle, connecting with image sensors. In the case of mobile, we have multiple image sensors, high resolution and mid resolution combined. And so these image sensors need to be connected to the application processor. So we may have additional ports on the input side, and then the application processor will drive the display. What we see often is an ISP between the image sensor and the application processor to improve the image quality, again, to enable that differentiation at the system level. And the same thing we're seeing on the display side, a dedicated processor, display processor sitting in the middle to apply specific techniques to improve the image quality, increase the refresh rates, etc. So here's an example of this diagram kind of represents that. In terms of relevant attributes, low power is paramount in automotive. Aggregation to be able to handle all these different sensors coming in. The bandwidth, because we're talking about very sophisticated image sensors producing a lot of data, so driving data at really high bandwidth. MPC compression for camera potentially coming in, and adapted refresh panel. That's definitely an important feature in mobile, because in mobile there are different use cases. You may be running a video or maybe just browsing menus. So there are different requirements in terms of refresh rate, which will basically impact the power consumption at the system level. So just double clicking on this on the display side, right? So camera is definitely important. That's probably the most important component that mobile OEMs kind of push in order to enable differentiation. But display is also equally important. That's my point here. There's a lot of innovations coming in here. The shift from LCD to AMOLED, the ability to upscale content, SDR content to HDR, the high refresh rates, the reduce the system power consumption, and basically enable a better user experience. And so talking about user experience, some of the techniques that we see in terms of being used in order to improve the user experience are listed here. Using AI. AI is a common theme here to improve the picture quality. So in this example, we're talking about a technique that basically does scene detection, whether it's a face or a landscape, and then will automatically adjust the image settings to enable better quality. Motion smoothing with MIPI. MIPI is not new. We've seen it in digital TV, but it's now coming into mobile, and it's particularly relevant for gaming, for example, where the idea is just to artificially add frames to a video with low frame rate. So basically, you can have compressed content at 24, 30 frames per second, and then run it at a higher frame rate. That's kind of the concept. And then finally, dynamic refresh rate with LTPO displays that will help extending the battery life, and again, enable a better user experience. Here's an example from Vivo, the X80, X80 Pro, using very well-known application processors from MediaTek or Snapdragon, depending on the product, on the version, but also combining that with their own chip that implements some of the techniques that I mentioned previously. And I want to jump to one of our customers, Novotech, how they implemented their display SoC. So Novotech is a leading fabless company specialized in display driver IC and SoC solutions. Novotech basically helps their customers to meet the emerging needs for sophisticated display requirements. So this is the diagram of the SoC. Has a couple of DSI inputs and DSI outputs that will drive the display, and also combines the CSI to TX interface, which I'll touch on that. So this SoC basically helps to improve the video quality and the image quality, and also includes things like increasing the refresh rates up to 100 and beyond. So this is how the chip fits in the system between the application processor and the display. And so the DSI output coming out from the application processor in mission mode, it goes through the input of the SoC, and then Novotech will apply the necessary techniques to improve the image quality and then drive that out to the display. Another use case is to shut down this data path and have just a bypass mode to enable that system level power savings. And finally, another interesting use case is with the CSI output, where when you're recording a video, the image coming from the image sensors, it's sent out to this chip that will apply image optimizations, image improving techniques, and then it will bring it back to the application processor so that it's actually recorded. So I think it's quite interesting. Now, moving to the third bucket. So we talked about automotive, mobile, and now just zooming into edge, AIoT, artificial things, edge, other imaging applications. though the common theme here is there's also the need to connect with a number of image sensors and drive displays with the processor in the middle in orange, whether it's AIoT or a vision processor. And here on the right side, I have a few examples. Some of our customers, DJI, that implemented their drone SoC and leverage our C-PHY solution to connect both with the high resolution image sensor that captures the image, but also other image sensors for the navigation as part of the solution. GML, a very interesting use case, a edge AI processor for machine vision in 12 nanometer, also with the camera input there using Synopsys IP. And then finally, SEMA, a machine learning platform for the embedded edge, also featuring an image sensor, an interface for image sensors. Now, I want to double click on another customer, Inuitive. I had a lot of fun putting this story together. So Inuitive is all about optimizing the consumer experience in AR, VR, robots, etc., and with AI at its core. And the NU4000 AI is a superior multi-core vision processor for 3D imaging, deep learning, and computer vision processing, again, for augmented reality, virtual reality, drones, robots, and other applications. It supports a high-quality depth sensing, also has SLAM on chip, simultaneous localization and mapping. That's what it means. The device needs to know its 3D position in the world. That's a requirement for example, AR applications. Also includes computer vision and deep learning capabilities implemented in 12 nanometer, and it supports connectivity up to 6 cameras and 2 displays. So on the right side, you see the image of where the NU4000 is used in the system. Now, from Inuitive's perspective, the common challenges for XR use cases are the fact that are listed here, the multiple sensors that are being used, loads of pixels, tight synchronization requirements, and fusion requirements. And this drives the need for to have heavy compute vision processing and extreme memory bandwidth needs, right? So that those are associated. On top of that, XR also requires low latency for optimal user experience. And at the end of the day, this is a battery operated device, so power consumption is also very important. And so how is Inuitive addressing these challenges? And when it comes to reducing the memory bottlenecks that I mentioned previously, they use a dedicated vision pipeline. So basically, they route the image coming from the image sensors to these processing pipelines, and then only the metadata is directed to memory, right? So the diagram here at the bottom, you can see on the left side a typical implementation where the processor collects the data, stores that in memory, and then there's some processing going on there. And Inuitive's approach is with that dedicated image pipeline, only the metadata is sent to memory, so it kind of reduces the memory bottlenecks. In terms of latency, reducing the motion to potent latency, right? The time between detecting the user's movement and the appropriate image refresh. So here, latency is important, and Inuitive's solution enables low latency here by using the concept of time warp. So on the diagram, if you see the diagrams on the left side, that's the typical implementation where when the detection the movement is detected with the sensors, the tracking sensors, and the inertial measurement unit. And then the application processor will take that in, and then we'll run the algorithm, the 6 degree of freedom algorithm, which is very common in this space, on the CPU, and then we'll drive the necessary updates to the GPU to refresh the data. This is that sequence of events makes sense, but obviously translates to significant latency. And so on the right side, Inuitive's approach is to have the dedicated entity, the dedicated NU4000, which will collect the data. It has a 6 degrees of freedom engine implemented, and will also have has the necessary pipeline to drive the refresh. So everything is offloaded from the main processor. And then finally, when it comes to connecting with the multiple image sensors, here we We did work closely with Inuitive and helping to provide more flexibility. And so basically, we provided a solution that allows them to, with the same set of pins, they have the flexibility to connect with different types of cameras with different resolutions. So here in this diagram, what I'm representing here is that with the same set of pins, you can connect 2 low resolution image sensors, but with software configuration upon startup, you can actually have the same set of pins to connect with 1 high resolution image sensor. So this flexibility is important because it all depends on what application the chip will be used in. The same concept applies to protocols. So with the same set of pin, with the same port, you can actually support different protocols with software configuration upon startup. And that's the conclusion. So we talked about relevant trends in MIPI in the market that are relevant to MIPI. We talked about we went through some use cases in mobile, automotive, and at the edge, IoT and imaging applications. And so the point here is that cameras and displays, they continue to be the focal point for mobile, consumer, and automotive applications. The requirements in terms of imaging continue to increase, high refresh rates, high resolutions, multiple cameras, multiple displays being used. And to satisfy all that, MIPI is the de facto interface in order to connect all these things together. And it continues to evolve to address the emerging requirements. Final point here at Synopsys, we continue committed and invested in delivering MIPI products that align with how the market evolves, and also make sure that we enable quick and low and very efficient integration. And this is kind of what I want to show here in my last slide that kind of represents our full suite for MIPI IP solutions for camera and display. We can address every single requirement on the sensor, application processor, and on the display side. We have D-PHY, C-PHY options in different nodes, supporting different bandwidths, up to 6.5 gigabits per second. And we have automotive grade IP. And basically our solution is fortunately widely adopted. We have a number of customers using our solution, which basically puts us in a really good position to provide a solid solution for any future requirements in terms of design. With that, thank you very much for your time. And I'll leave you with an additional resource. If you want to know more about our Synopsys offering for MIPI IP, please follow this link. And with that, thank you very much for your time.